we finding kinetic energy and now total energy kinetic energy and potential energy. In the spring, total energy, kinetic energy and potential energy. Let a mass capital M connected at one end of the spring, another end of the spring is fixed, and the natural length of the spring, that is equal to capital L. If we displace this mass up to a distance A, A is amplitude. रेस्ट से हमने mass m connected to the end of the spring and we displaced up to A and we released. From this position, this mass is at rest, and this maximum distance, we increase the length of spring, that is equal to amplitude. Now we release this block from this position. Then due to force by the spring F, it moved in this direction, and this block not stay at this position. This is the equilibrium position. So this block when comes out here, then at this position x is equal to 0, and at this position x is equal to A. Then at this position block is not at rest. From this position rest, it increases its kinetic energy, and when it's come here, then extension in the spring is 0. So at this position potential energy is 0, and at this position kinetic energy is 0, and at this position potential energy is maximum, is equal to half k A square. Half k A square, and kinetic energy 0. So this is the total energy stored in the spring. This is the total energy, half k A square. But when it comes to here, when release this block from this position to this position, then at this position potential energy is 0, and kinetic energy is equal to maximum kinetic energy. The potential energy at this position, that is total energy at this position, converts into kinetic energy at this position, because at this position potential energy is 0. So at this position kinetic energy is maximum, that is half k A square. Half k A square. Kinetic energy at this position half k A square. Now this block move from this position, frictionless surface, it is seen that it move from this position to this position. Again it move up to amplitude because there is no loss of energy, and at this position kinetic energy is 0 and potential energy is maximum, is equal to half Ka square, is equal to total energy. So we release the block from this position, from rest, which is the amplitude of this motion. Block move with some velocity and it crosses the block move from rest due to force exerted by spring from this position, and at this position the total potential energy, here kinetic energy is 0, so total energy is potential energy, that is half Ka square, and from this position to this position that potential energy converts into potential energy, and at this that potential energy converted, that potential energy convert at this position in kinetic energy. At this position kinetic energy is maximum, and now block move in this direction. Now again it move up to amplitude A because there is no loss of energy, and at this position whole kinetic energy or at this position, which is total energy, converts into potential energy, and again this is the maximum position of block, amplitude position. Again kinetic energy at this position 0 and potential energy at this position is total energy half Ka square. So this type of motion, this block move this type of motion, to and fro motion, we will study also in simple harmonic motion. It is very important topic. Now for the energy graph of kinetic energy, potential energy and kinetic energy, here x is equal to 0, here x is equal to plus a, here x is equal to minus a, and at x is equal to 0 position potential energy is 0, and at this position this is the potential energy curve and this is the kinetic energy. At x is equal to 0 potential energy becomes 0 and total energy, which is constant, converts kinetic energy, total potential energy converts into kinetic energy at x is equal to 0 position. As we release block from this position, that when this block comes to this position, then total potential energy converts into kinetic energy. At this position kinetic energy is maximum, which is equal to total energy, and this is the total energy which is constant, and at amplitude position kinetic energy becomes 0 and potential energy is maximum, which is equal to total energy. At this position x is equal to 0, kinetic energy maximum, total energy, and x is equal to minus a. Again at this position kinetic energy is 0 and potential energy at this position maximum is equal to total energy. This is the curve. As we release the block from amplitude position, then when it moves from amplitude position to 0, kinetic energy maximum, potential energy 0. At maximum position amplitude, potential energy maximum, kinetic energy 0. So kinetic energy at x is equal to 0 is equal to total energy at this position. Kinetic energy is equal to total energy at this position. Potential energy is equal to total energy at this position. Potential energy is equal to total energy, and total energy is constant because there is no friction. So this is the discussion of potential energy stored in the spring. Now you can apply this very important discussion about the spring.